Here in introduction, you can see that some of the experimental phenomena such as diffraction and interference can be explained by the wave nature of the electromagnetic radiation, whatever I described in the previous class 016. But some of the observation cannot be explained by this wave nature of the electromagnetic radiation. That's why the particle nature of the electromagnetic radiation has come in the picture. So what is those observations? Number one, the nature of emission of radiation from hot bodies. That means black body radiation. Number two, ejection of electrons from the metal surface when the radiation strikes in, it is called the photoelectric effect. So black body radiation can be explained by the wave nature of the electromagnetic radiation, and also the photoelectric effect cannot be explained the wave nature of electromagnetic radiation. Number three, the variation of the heat capacity of the solid as a function of temperature, that also cannot be explained by the wave nature of the electromagnetic radiation. And that's why the particle nature of electromagnetic radiation has come in the picture. And another one which also cannot be explained by the wave nature of the electromagnetic radiation, that is the line spectra of the atoms with special reference of the hydrogen. So these all phenomena indicates, what it indicates? That the system can take the energy only in discrete amounts. If it is continuous energy taking, then it is the wave nature of the electromagnetic radiation. But it is not like that. It is coming as a discrete amounts. So all possible energies cannot be taken off or radiated. Only discrete amounts, not all amounts can be taken off. So Max Planck in the year 1900 explained the phenomenon of the black body radiation. Before going to the Max Planck's quantum theory or equation, we will see what is the black body radiation. Black body is an ideal body which emits and absorbs radiations of all frequencies uniformly. And that ideal body is called the black body. And whatever the radiation emitted by such type of body is called the black body radiation. So now it is very clear what is the black body, what is the definition of it, and what is the black body radiation. Black body emits and absorbs the radiation of all frequencies uniformly, and that radiations emitted is called the black body radiation. But in practice, no such body exists. Only the carbon-related black body is closely related to this black body. Now we'll see second phenomena, radiation by hot objects. What is this? Hot objects emit electromagnetic radiations over a wide range of wavelength. At high temperature, an appreciable proportion of the radiation is in the visible range of the spectrum. We'll give the example. As the temperature is raised, a higher proportion of short wavelength, that is blue light. Blue light is the short wavelength, red light is the long wavelength. So at the temperature, when it is going to be high and higher, then a higher proportion of short wavelength, that means blue light, is generated. Example, an iron rod. Consider about the iron rod. When it is heated in the furnace, then first it turns a dull red, and then progressively becomes more and more red, that means bright red. When heating is more, then bright red is coming as the temperature increases. As this is heated further, then the radiation emitted becomes white, and then becomes, again if it is red, then it is blue, when the temperature becomes very high. So, red radiation is most intense, no doubt, at a particular temperature, and the blue radiation is much more intense in another temperature. Intensities of radiations of different wavelengths emitted by hot body depends upon its temperature. So then the Planck assumed that this radiation could be subdivided into discrete chunk of energy. This is the assumption by the Planck to explain the all phenomena, whatever the previously we described. So what he suggested? He suggested that atoms and molecules could emit or absorb energy only in discrete quantities, not in the continuous manner. So we understood that Planck suggestion is whatever the energy from atoms or molecules will emit, or the atoms or molecules will absorb this in the discrete quantities, not in the continuous manner. So these discrete quantities named is a quantum, to the smallest quantity of energy that can be emitted or absorbed in the form of the electromagnetic radiation. This is very landmark assumption by the Planck in the field of the science. That quantum, this word first coined by the Planck. So he has given one equation. If the energy is the capital E of a quantum of radiation, then it is proportional to its frequency nu and is expressed by equation E is equal to h nu. And in this case, this h is the proportionally constant, and it is known as the Planck constant, and its value is the 6.626 multiplied by 10 to the power minus 34 joule dot second. So with this theory, Planck was able to explain the distribution of intensity in the radiation from black body as a function of frequency or wavelength at different temperature. So now he is able to explain with this equation that whatever the distribution of the intensity in the radiation from the black body, it is the function of frequency or wavelength. Frequency means nu and wavelength is the lambda at different temperatures. So the quantization, how do you imagine? Just you imagine on the staircase at your home, and when a person will stand in any step of the staircase but not in between the staircase. When staircase not started, so 0, 1, 2, 3, 4, in this way you can step up, but in between the staircase there is not possibility to put your foot there. Similarly, the energy can take any one of the values from the following set. That means the energy emitted or absorbed, it will be either 0 or h nu, 2h nu, 3h nu, and dot dot n h nu, where the small n is a number. So now we understood that why Planck's theory has come, what is the quantums, and some phenomena is there cannot be explained by the wave nature of the electromagnetic radiation. That's why particle nature has come to the picture for the electromagnetic radiation, and explanation with different example has been given here with the Planck's quantum